Good morning, student. This is Latif, sir. Today I am going to discuss about equivalent weight. Equivalent weight, which is represented by E, capital E. Like molecular weight, equivalent weight also measures the quantity or of matter, okay, or amount of matter. So using equivalent weight, you can measure the quantity or amount of a substance. An equivalent weight, it is defined as the mass of element or compound or ion which combines or displaces 1 part of hydrogen, 8 part of oxygen and 35.5 parts of chlorine by mass. So equivalent weight, it is defined as the mass of an element or compound or ion which combines or displaces 1 part of hydrogen or 8 part of oxygen or 35.5 parts of chlorine. So equivalent weight can be represented in terms of hydrogen, in terms of oxygen or in terms of chlorine. Okay, this is the definition of equivalent weight. Now there is a relation between equivalent weight, molecular weight and valence factor, that is valency. And the relation between equivalent weight and molecular weight is equivalent weight is equal to molecular weight divided by valence factor, that is m0 by x, where m0 is molecular weight divided by x. And this is for molecule or compound. This relation is valid for molecules, that is this equation is valid for compounds. Okay, and for atom, in the case of an element, in the case of an element, the equivalent weight is defined as equivalent weight is equal to atomic weight divided by valency or valence factor, atomic weight divided by valency. And atomic weight is denoted by A, capital A, and valency is x, then equivalent weight E is equal to A by x. And this equation is valid for element, okay, valid for atom. Now valency, valency of hydrogen is 1, valency of calcium is 2, valency of oxygen is 2, valency of aluminum is 3. You have already studied in class 7 8, okay, about valency. So valency of hydrogen is 1. So equivalent weight of hydrogen atom is atomic weight of hydrogen divided by valency of hydrogen. So atomic weight of hydrogen is 1. So equivalent weight of hydrogen is equal to 1 divided by 1, because valency is also 1. So equivalent weight of hydrogen atom is 1. Similarly, equivalent weight of calcium is equal to atomic weight of calcium divided by valency of calcium. So atomic weight of calcium is 40 and valency of calcium is 2. So 40 divided by 2, that is 20. Similarly, equivalent weight of oxygen atom is equal to atomic weight of oxygen is 16. So 16 divided by 2, that is 8. Now equivalent weight of an acid. An equivalent weight of acid is equal to molecular weight of acid divided by basicity of the acid. Here you have to exchange the valence factor in terms of basicity. Okay, so equivalent weight of an acid is equal to molecular weight of acid divided by basicity of the acid, and the basicity of an acid is equal to the number of ionizable hydrogen or protons, ionizable hydrogen ion, that is H plus ion or protons in its aqueous solution. So equivalent weight of acid is equal to E equal to molecular weight of acid divided by basicity of the acid. For example, basicity of sulfuric acid H2SO4 is 2, because sulfuric acid contains two hydrogen ionizable or ionizable hydrogen atoms. So basicity of sulfuric acid H2SO4 is 2. So equivalent weight of sulfuric acid is equal to molecular weight of H2SO4 sulfuric acid divided by 2. And you have to calculate molecular weight of sulfuric acid. So molecular weight of sulfuric acid is 98. So 98 divided by 2, that is 49, is the equivalent weight of sulfuric acid. Similarly, you can calculate equivalent weight of phosphoric acid. So equivalent weight of phosphoric acid chemical formula is H3PO4. H3PO4. So equivalent weight of phosphoric acid will be molecular weight of phosphoric acid divided by 3, because phosphoric acid has 3 ionizable hydrogen ion, H plus ion. So you have to divide the molecular weight of phosphoric acid by 3. Okay. Here one point you have to remember, that basicity is not same as the number of hydrogen atom in acid molecule. It is not always same. Basicity and the number of hydrogen atom present in one atom, one molecule of the molecule is not same. For example, acetic acid contains total acetic acid CH3COOH, which contains total hydrogen 4 hydrogen atoms. Total 4 hydrogen atoms. But the basicity of acetic acid is only 1, because acetic acid can produce only one H plus ion. Similarly, phosphorus acid H3PO3, not phosphoric, it is phosphorus H3PO3. So in phosphorus acid there are total 3 hydrogen atoms, but the basicity of phosphorus acid is 2, because phosphorus acid can produce only 2 hydrogen atoms. So equivalent of weight of phosphorus acid is equal to molecular weight of phosphorus acid divided by 2, not divide by 3. Okay, so molecule equivalent weight of phosphorus acid is equal to molecular weight of phosphorus acid divided by 2. Similarly, you can calculate the equivalent weight of bases. The equation will be similar to and the equation for calculation of equivalent weight of bases is equivalent weight of base is equal to molecular weight of base divided by acidity of the base. Similar equation, just you have to replace basicity in terms of acidity. What is acidity of base? Acidity of base is the number of OH minus ion, present in the base. For example, calcium hydroxide CaOH whole twice. So calcium hydroxide contains 2 OH minus ion. So equivalent weight of calcium hydroxide, that is equivalent weight of calcium hydroxide, will be molecular weight of calcium hydroxide divided by 2, because calcium hydroxide contains 2 OH minus ion. So acidity of calcium hydroxide will be 2. Okay, similar equation. In case of bases, you have to replace the basicity in terms of acidity. Okay. And you can also calculate the equivalent weight of radicals, such as equivalent weight of sulfate, equivalent weight of phosphate radical, equivalent weight of nitrate radical, equivalent weight of carbonate radical. Just you have to remember the formula of radical. For example, formula of carbonate radical is CO3 2 minus. CO3 2 minus. It is wrongly written as CO3 2. Just correct it. Okay. CO3 2 minus. It is carbonate radical. So number of electronic charge on carbonate radical or carbonate anion is CO3 2 minus charge. So hence equivalent weight of carbonate radical or carbonate ion is molecular mass of CO3 radical divided by 2. Okay, so you have to divide by 2, because and molecular mass of CO3 2 minus radical is 60, so you have to write 60 divided by 2, that is 30. Okay, so equivalent weight of carbonate ion is 30. Similarly, equivalent weight of aluminum ion is equal to atomic mass of aluminum, that is Al, and atomic mass of aluminum is 27, and charge of aluminum 3 plus ion is 3 plus, so you have to divide 27 by 3. So equivalent weight of aluminum 3 plus ion is 27 divided by 3, that is 9. Okay. Now equivalent weight of an oxidizing or reducing agent. How to determine the equivalent weight of oxidizing or reducing agent? In a redox reaction, one of the reacting agent is oxidizing agent and the other reacting agent is reducing agent. The oxidizer is the oxidizing agent. The oxidizing agent which oxidizes the other substance, that is okay, and reducing agent, that means which reduces the other substance. So how to calculate the equivalent weight of oxidizing and reducing agent? So in this case, you have to remember the number of electrons transferred in redox reaction. In this case, you have to remember the number of electrons transferred in the redox reaction. So equivalent weight of oxidizing or reducing agent is molecular weight of the compound divided by number of electrons transferred in the redox reaction. Okay, for example, potassium dichromate K2Cr2O7. In acidic medium, potassium dichromate, it becomes in acidic medium, it is strong oxidizing agent. It means it gains electron during redox reaction. And the reaction of potassium dichromate in acidic solution is K2Cr2O7 plus 14H plus 6 electron implies 2K plus 2Cr3 plus 7H2. This is the reaction of potassium dichromate in acidic solution. So equivalent weight of potassium dichromate will be equal to total molecular weight of potassium dichromate, that is 294.2 divided by number of electrons transferred in this redox reaction. You can see according to the reaction, the total number of electrons transferred is 6. So equivalent weight of potassium dichromate is 294.2 divided by 6, that is it nearly about 29. So equivalent weight of potassium dichromate is 29. Okay. Now gram equivalent weight. What is gram equivalent weight? It is equal to the mass in gram, numerically equal to equivalent weight. For example, suppose equivalent weight of sulfuric acid is 49. So what is gram equivalent of sulfuric acid? It is 49 gram. That means 49 gram sulfuric acid means 1 gram equivalent of sulfuric acid. If the mass of chemical entity is in gram, then the given mass contain gram equivalent by the equation. That is, you can calculate gram equivalent, which is represented by GEQ, equal to mass divided by equivalent weight. You can calculate the number of gram equivalent by using the equation mass of the given mass of the substance divided by equivalent weight of the substance. For example, suppose 98 gram sulfuric acid provided. So what is the number of gram equivalent of sulfuric acid? 98 divided by equivalent weight of sulfuric acid. And you know equivalent weight of sulfuric acid is 49. So 98 divided by 49, that is 2 gram equivalent H2SO4 sulfuric acid. Okay. So today I have discussed about equivalent weight and how to calculate equivalent weight of different substances, that is equivalent weight of acids, equivalent weight of bases, and equivalent weight of oxidizing and reducing agent, and gram equivalent. Okay, you have to remember the formulas or relations. Okay, thank you.